There is a stone in the highlands of Ethiopia that weighs 500 tons. It was cut from a single piece of granite, shaped into a tapered column over 30 meters tall, and somehow raised to a vertical position, only to fall at some point in antiquity, cracking the earth beneath it in a way that tells researchers it landed with tremendous force. The people who erected it left no written record of how they did it. The civilization they belonged to is only partially understood, and the stone itself, lying on its side in a field, is still the largest monolith ever successfully quarried and raised in the ancient world. That particular record, largest ever moved, largest ever erected, tends to shift depending on where you look, and that, perhaps more than any single measurement, is the part worth sitting with. There are so many candidates for the title that the competition itself becomes its own kind of evidence. Across the ancient world, separated by oceans and millennia, and the vast differences between cultures that never had any documented contact with one another, human beings did something extraordinary and poorly understood. They moved stone, not pebbles, not building blocks. They moved objects so massive that modern engineers, running the calculations, still argue about whether the methods we attribute to those builders were actually sufficient for the task. They shaped those objects with a precision that sometimes exceeds what we would expect from the tools available. And they arranged them in configurations, alignments, circles, platforms, temples, that frequently demonstrate an awareness of astronomy, geometry, and landscape that implies a depth of knowledge we have not fully accounted for. The question that runs underneath all of it is not a dramatic one. It does not require mystery for its own sake. It is simply this: how did they do it? And what does the gap between our best explanation and the physical reality of the object in front of us actually mean? We are going to examine 5 structures where that gap is real, documented, and unresolved. 5 places where stone was worked at a scale and precision that continues to generate genuine debate among researchers. 5 sites that, taken together, say something about human capability in deep antiquity that we are still trying to understand. Stand at the base of the outer wall at Sacsayhuaman, and the immediate experience is one of sheer displacement. You are looking at stones, some of them, that weigh over 100 tons, fitted together without mortar in a configuration of interlocking angles so complex that no 2 adjacent blocks share the same face geometry. And yet they meet. Every surface, every projection, every recessed angle fits against its neighbor, with a precision that has survived 5 centuries of Andean seismic activity, including earthquakes that leveled the Spanish colonial city built directly below it. The site sits above the city of Cusco in the Peruvian highlands at an elevation of roughly 3,700 meters, and it was a functioning construction of the Inca Empire in the 15th century. That much is documented. The Inca built here. Spanish chroniclers recorded the project, noted the staggering labor involved, described the ramps and the ropes and the tens of thousands of workers conscripted through the Maitiar labor system. In the Inca administrative framework, large-scale coordinated labor was a genuine institutional capability. The empire ran partly on it. The broadly accepted explanation for Sacsayhuaman is therefore not mysterious in its outline. Massive organized labor, purpose-built infrastructure for dragging stones across the terrain from quarries several kilometers away, and an Inca engineering tradition that, while not fully documented in technical detail, produced results across multiple sites that speak to sophisticated planning capability. This explanation is credible. It accounts for the labor. It accounts for the logistics. What it leaves less resolved is the precision. The polygonal masonry at Sacsayhuaman does not follow the pattern of most large stone constructions, ancient or modern. Large blocks are typically squared, which makes fitting straightforward. At Sacsayhuaman, the blocks are deliberately irregular, each one shaped to a unique multi-sided geometry that interlocks with its specific neighbors and no others. The larger the block, the more complex the interlocking tends to be. A block weighing 100 tons may have a dozen or more distinct angled faces, each of which must fit exactly against the corresponding surface of an adjacent block. Shaping one side of that joint is a significant undertaking, shaping both sides of the joint so that they meet perfectly, and doing this for a wall that extends for over 300 meters. is something else. Researchers studying Andean masonry have proposed that the Inca used a process of iterative fitting, shaping a surface partially, pressing it against its neighbor to find the high points, grinding those down, and repeating the process until the fit was achieved. This technique is credible and has parallels in other ancient masonry traditions. The question is one of scale and time. At the size of Sacsayhuaman's largest blocks, iterative fitting between 200-ton stones requires moving both of them repeatedly, an enormous logistical undertaking in its own right. The time required, multiplied across the full extent of the walls, generates numbers that some researchers consider inconsistent with the construction timeline suggested by historical sources. There is also the matter of the quarries. The primary stone at Sacsayhuaman is a limestone found at Yucay, roughly 15 kilometers away, and an andesite sourced from quarries even further in the opposite direction. Moving either material across the terrain between quarry and site, terrain that includes river crossings, significant elevation changes, and no flat road, required a logistical operation of considerable complexity. The physical evidence of ramps and drag paths has been identified at some Inca sites, though the evidence at Sacsayhuaman specifically is less complete than researchers would like. What the site ultimately presents is an achievement that is almost, but not quite, fully explained by the capabilities we have documented for its builders. The gap is not enormous, but it is consistent, and it persists across every technical analysis that takes the precision seriously. How did they work stone of this mass to tolerances this tight, and why did they choose a system that made the task harder than it needed to be? From ground level, it looks like a field of scattered basalt rubble, the kind of rough, irregular stone common across the volcanic plateau of the Golan Heights. You could walk through it without fully understanding what you were standing inside. It is only from the air that Rujum el-Hiri reveals itself. 5 concentric rings of stone, the outermost nearly 160 meters in diameter, connected by radial walls, enclosing a central burial cairn that rises several meters above the surrounding plain. From above, the structure looks less like something built and more like something drawn, a geometric pattern of enormous precision imposed on the landscape by a hand operating at a scale that the terrain itself cannot hint at from the ground. The name translates from Arabic as "stone heap of the wild cat," which does not begin to capture what the structure actually is. It sits on the basalt plateau of the southern Golan Heights in what is now northern Israel, and it was built, current dating estimates suggest, somewhere between 3000 and 2700 BCE, placing it in the early Bronze Age. The people who built it have not been identified with certainty. No written record accompanies it. No clear cultural attribution has been established with the confidence that archaeologists typically require before making firm claims. It simply exists: 5 rings, a central cairn, approximately 40,000 tons of basalt stone, stacked without mortar into walls that, in places, still stand over 2 meters tall. The scale of the labor investment is the first thing that demands attention. 40,000 tons of basalt, gathered from the surrounding plateau, carried to the site, and arranged into a geometric configuration that required the builders to maintain consistent curvature across rings spanning hundreds of meters. This is not a task that can be accomplished by a small, loosely organized group working opportunistically. It requires planning at a level that defines the final form before construction begins, a conceptual grasp of the whole structure that must be held in mind while working incrementally on its parts. The mainstream interpretation among archaeologists is that Rujum el-Hiri served a funerary and possibly a ritual or territorial function. The central cairn, when partially excavated, was found to contain a burial chamber, a dolmen-style structure of large stone slabs forming a small internal space. Burials associated with this type of monument are known across the Levant and the broader ancient Near East, and the placement of such monuments in visible locations on the landscape is thought to be connected to marking territory, honoring ancestors, or anchoring a community's claim to a particular region. This interpretation is reasonable and consistent with the broader regional pattern. What resists easy resolution is the astronomical dimension. Researchers studying Rujum el-Hiri have documented that its northeastern gateway, a specific opening in the outermost ring, aligns with the rising sun at the summer solstice. This is not a rough or approximate alignment. On the solstice, an observer standing at the central cairn and looking through the northeastern opening watches the sun rise precisely framed within the gap. The alignment holds at the documented construction date, accounting for the slow drift of the solar position over millennia. Whether this alignment was intentional, and if so, what it implies about the astronomical knowledge of the builders, is a question the site cannot answer on its own. Intentional solar alignments are known at other megalithic sites across the ancient world. Newgrange in Ireland, certain configurations at Stonehenge, several sites in the Iberian Peninsula. The existence of such alignments, if deliberate, implies a sustained tradition of observational astronomy, the ability to track the solar year with sufficient precision to identify the solstice point and then encode that observation into a stone structure built to last. At Rujum el-Hiri, that tradition would have been operating in the early Bronze Age Levant, a context in which the astronomical sophistication suggested by the alignment does not have obvious parallel in the surrounding archaeological record. The site has been only partially excavated. The logistics of full excavation at this scale, 40,000 tons of stone across a 160-meter diameter, have limited systematic investigation. Much of what the interior of the rings might contain remains undisturbed and unstudied. Who built it? Precisely when each ring was added, whether the full structure was conceived as a unified plan or accumulated incrementally over generations, these questions remain open. A monument visible from the air but nearly invisible at ground level, aligned to a celestial event with precision that implies careful observation, built by a people who left no name for themselves in the record. What were they marking and for whom? Built on a tidal flat off the eastern coast of Pohnpei Island in the Western Pacific, Nan Madal is a city constructed entirely on artificial islands, 92 interlocking platforms of coral rubble and basalt, separated by a network of tidal canals, covering an area of roughly 83 hectares. It was the ceremonial and political center of the el-Hiri dynasty, which ruled Pohnpei from sometime around the 9th century CE until approximately 1628. It is the only ancient city in the world built entirely over open water, and it is made in its most substantial structures from basalt logs, hexagonal columns of volcanic rock, some reaching 5 meters in length and weighing several tons, stacked in a log cabin pattern to form walls that, in certain enclosures, rise 9 meters from the water. The visual effect is extraordinary and slightly disorienting. Massive dark basalt columns interleaved in alternating layers, rising from the ocean, half consumed by mangrove roots and the accumulation of vegetation over centuries of abandonment. The largest enclosure, Nan Madal, which served as the royal mortuary complex, has walls 4 meters thick at the base. The total volume of basalt incorporated into Nan Madal's structures has been estimated at somewhere between 750,000 and 1 million tons. The source of the basalt is known. The columnar basalt used in Nan Madal's construction comes from several quarry sites around Pohnpei, the most significant of which is at Sokis on the opposite side of the island, roughly 25 kilometers from Nan Madal by the coastal route. Moving multi-ton basalt columns from those quarries to the construction site across open ocean required watercraft capable of carrying substantial loads and navigating the currents and weather of the Western Pacific. Ethnographic accounts and oral traditions on Pohnpei describe the columns being transported by raft, which is plausible in principle. No physical evidence of the rafts or the transport infrastructure survives. The organizational challenge is worth dwelling on. Nan Madal was built in stages over several centuries, with the most intensive construction activity associated with the el-Hiri dynasty's period of greatest power. The workforce required to quarry, transport and stack basalt at this volume, while simultaneously building and maintaining the artificial island platforms themselves, which required continuous management to prevent erosion by tidal action, was substantial. Pohnpei's population during the peak construction period has been estimated at somewhere in the range of 25 to 30,000 people, mobilizing a significant fraction of that population for a sustained construction project, while the island's food production continued to function, implies an administrative and political structure of considerable sophistication. What the accepted explanation struggles to fully account for is the precision of the basalt stacking in certain structures. Columnar basalt is naturally angular and relatively uniform in cross-section, which makes it more stackable than irregular stone. But the columns at Nan Madal are not simply piled. They are arranged in an alternating horizontal pattern that distributes load and creates structural stability, with specific attention to the orientation of each layer. In the best preserved sections of the outer walls, the coursing is consistent across the full height of the structure in ways that imply careful planning and quality control at each stage of construction. Local oral tradition holds that the founders of Nan Madal, two brothers named Olisipa and Olosopa, who arrived from a distant land called Kanimweso, used magic to float the basalt columns to the site. Every culture has its founding myths, and this one is no different in that sense. But the specific detail of the columns floating, moving through the ocean by a means the tradition cannot fully explain, may preserve in transformed form a memory of a transport method that was genuinely remarkable by any standard available to the people who witnessed it. The city was abandoned in the 17th century, possibly following a successful revolt against the Sodalur rulers, possibly because the political and agricultural systems that sustained it collapsed under their own complexity. The canals are still navigable by small boat. The walls are still standing, salt-weathered and root-threaded, rising from the Pacific. A city built on water for a dynasty that no longer exists, constructed by methods that the oral tradition could only describe as miraculous. What sustained the will and the capability to build an entire capital on the open ocean? We are midway through, and the question that opened this investigation remains exactly where it was. How did they do it? And what does the persistent gap between our best explanation and the physical reality in front of us actually mean? Three very different cultures, three very different regions of the world: the Andean highlands, the Pacific lowlands of Central America, the open ocean of Micronesia, the Inca, the Dikis, the Sodalur. No documented contact between them, no shared tradition that we know of. And yet the same pattern appears in all three cases: construction at a scale and precision that our analysis can almost, but not quite, fully account for. Not dramatically, not impossibly, but consistently enough that the gap doesn't close, regardless of how carefully we look. That consistency is what the next two sites press harder on. What follows involves stone moved at a scale that makes the previous examples feel, in some sense, preliminary. Most people who visit Nanjing go to see its city walls, its temples, its history as a Ming dynasty capital. Very few travel to the low hills of Yangshan, a few kilometers outside the city, to look at a stone that never moved. In the early 15th century, the Yongle emperor ordered the quarrying of a massive commemorative stele, a ceremonial stone monument, to honor the Hongwu emperor, his father and the Ming dynasty's founder. The work began at Yangshan, where the local granite was of suitable quality and scale, and the scale the emperor envisioned was extraordinary, a stele so large it would dwarf every previous monument in Chinese history. Work proceeded. Stone was cut. Three separate sections were quarried: the base, the body, and the capstone, each in its own enormous excavation. Then the project stopped. The stones were left in their quarry cuts where they remain today. The numbers are not easily absorbed on first encounter. The largest of the three sections, the stele body, is approximately 49 meters long, 10 meters wide, and 13 meters thick. Its weight has been estimated at somewhere between 16,000 and 30,000 tons, depending on the calculation methodology. If the three sections had been successfully moved and assembled, the completed monument would have stood over 70 meters tall, nearly twice the height of the Statue of Liberty. It would have been the largest stone monument ever constructed by any civilization in human history. The reason the project was abandoned is not fully documented. The prevailing interpretation among historians is that the engineers realized at some point during or after the quarrying phase, that moving stones of this mass was simply not achievable with the methods available to them. The infrastructure required, the ramps, the sleds, the workforce, the route preparation, was either beyond what the dynasty could mobilize or beyond what the physics of the available technology permitted. The stones were left where they were cut, and the stele was never built. What makes Yangshan significant in this context is precisely the abandonment. It is a rare case where an ancient civilization got far enough into an impossibly large construction project to leave behind direct physical evidence of the attempt, and stopped before completion. The quarry cuts around the three sections are clean and deliberate. The shaping of the stone surfaces is advanced. This was not a preliminary sketch. This was a serious effort by one of the most powerful and administratively sophisticated states in the 15th century world, with access to enormous labor resources, advanced material engineering, and a tradition of monumental construction that had produced the Forbidden City and the Great Wall. And they concluded they couldn't move it. That conclusion, from that source in that era, is informative in ways that extend beyond the Yangshan project itself. If the Ming dynasty, with all of its institutional capability, determined that moving a 30,000-ton stone was not feasible, then when we look at other ancient sites where stones of comparable or even greater mass were successfully moved, the question of how takes on additional weight, not as mystery for its own sake, as a genuine engineering problem that deserves more rigorous analysis than it typically receives. The three sections of the Yangshan stele still lie in their quarry cuts today. They are a tourist site now, accessible by path, surrounded by explanatory signage. Visitors can walk alongside the largest section and look up at a stone as tall as a 4-story building, shaped but unfinished, abandoned in place for 600 years. A monument to the moment when ambition and capability met the boundary between them. What would it have taken for them to succeed? And if others with less administrative infrastructure somehow managed comparable tasks, what did they know that the Ming engineers didn't? There is a stone doorway in the Bolivian Altiplano that stands alone in a field, slightly tilted on its axis, cracked vertically through its upper section by some ancient geological event. It is called the Gateway of the Sun, and it was carved from a single block of andesite, a single block, weighing approximately 10 tons. That is not what makes it remarkable. What makes it remarkable is what is on it. The upper portion of the gateway is covered in a carved relief of extraordinary density and precision. At the center stands a frontally positioned figure, generally identified by researchers as the primary deity of the Tiwanaku culture, holding staffs in each hand, radiating lines and heads, surrounded by 48 winged figures in 3 rows, arranged symmetrically on either side. The carving extends across the full width of the doorway's upper register without interruption. Every figure is rendered with consistent proportionality. The relief depth is uniform across the surface, and the entire composition was carved on a block of andesite, one of the harder volcanic rocks, with no tool marks indicating rework or correction. The Tiwanaku culture occupied the Lake Titicaca Basin from roughly 300 CE to 1000 CE, and the site of Tiwanaku, from which the gateway comes, was their ceremonial capital. The site covers several square kilometers and includes platforms, semi-subterranean courts, and a stepped pyramid called the Akapana that rises 10 meters from the surrounding plain. Within the site and its immediate environs, researchers have found evidence of sophisticated bronze metallurgy, a formalized artistic tradition expressed across ceramics, textiles, and stone, and an agricultural system involving raised field cultivation on a significant scale. The Tiwanaku were not a simple society, but the Gateway of the Sun represents a concentration of technical achievement that stands somewhat apart even within their own output. Carving a composition this dense and this consistent on andesite, in relief, with the tools documented for the Tiwanaku, primarily stone hammers, bronze chisels, and abrasive stones, is a task that would require extraordinary precision, sustained across the full working time of the piece. Andesite does not forgive mistakes the way softer stone does. A carving error on limestone can sometimes be masked by extending the surrounding surface. On andesite, a slip changes the finished piece permanently. No preparatory marks have been identified on the gateway's surface. No guidelines, no grid, no sketched outlines that would indicate a transfer from a smaller design. The composition appears to have been executed directly into the stone at full scale from the beginning. Whether this reflects a tradition of highly skilled freehand carving, or whether some form of grid or transfer system was used and then removed, is a question the stone itself cannot answer. The gateway was not found standing upright in its original position. When researchers began serious study of the Tiwanaku site in the 19th century, it was partially buried and heavily tilted. Its original setting within the site's architecture is still debated. Some analyses suggest it served as a doorway into an enclosure. Others propose it was a freestanding ritual monument. The crack through its upper section occurred at some point in antiquity, possibly during a seismic event, and the two halves have shifted slightly relative to each other, which means that when the carving was intact, the symmetry of the composition extended seamlessly across a surface that is now fractured. Then there is the Bennett monolith. Excavated from within the Tiwanaku site in 1932 by the American archaeologist Wendell Bennett, the monolith is a standing stone figure nearly 7.5 meters tall and weighing approximately 20 tons. It depicts a human form in a highly stylized manner. The same iconographic language as the Gateway of the Sun, rendered at a scale that required quarrying, transporting, and erecting a block of stone taller than most of the buildings in the contemporary town of Tiwanaku. The surface of the monolith is covered in carved detail from the feet to the crown: belts, tunics, headdresses, ceremonial objects held in both hands. The carving wraps continuously around the figure, requiring that every surface of the stone be accessible and workable during production. What this means practically is that the stone had to be oriented, rotated, and repositioned throughout the carving process at 20 tons, a significant engineering undertaking, while maintaining a consistent reference to the overall composition. The figure's proportions are intentional and controlled. The iconographic elements are consistent with the Tiwanaku artistic canon expressed elsewhere in the culture's output, scaled up to monument size without degradation in precision. The monolith was moved from the site in 1932 and eventually placed in a museum in La Paz, where it remained for decades before being returned to Tiwanaku. The excavation records from Bennett's original dig document the context it was found in, a semi-subterranean sunken court lined with stone heads. But the original means by which it was erected at the site and the full significance of its placement within the ceremonial complex remain subjects of ongoing research. Taken together, the gateway and the monolith represent something that the Tiwanaku appear to have done with unusual consistency, producing technically demanding stone objects at the intersection of large scale and fine detail. These two qualities tend to work against each other in stone carving. Scale introduces problems of proportion, access, and material management. Fine detail requires sustained precision at close range. The Tiwanaku navigated that tension repeatedly at a site sitting at 3,800 meters above sea level in a landscape with limited timber resources and a population that was, by our best estimates, substantially smaller than the civilizations that produced comparable achievements elsewhere. How a culture of that size, in that environment, sustained a tradition of stone carving at this level, and what the full inventory of their production actually looked like before centuries of looting, displacement, and natural deterioration reshaped the site, is a question the current state of research at Tiwanaku has not finished answering. What the Gateway of the Sun and the Bennett monolith together suggest is that the Tiwanaku understood something about working stone at scale that we haven't fully translated into our reconstruction of their methods. The question that ran beneath all 5 of these places was not about magic or lost technology or civilizations more advanced than our own in some sweeping, dramatic sense. It was a quieter question. How did they do it? And what does the gap between our best answer and the object itself actually tell us? 5 structures, 5 cultures, 5 regions of the world with no documented connection to one another. Sacsayhuaman, with its interlocking polygonal blocks fitted to tolerances that have resisted 5 centuries of earthquakes. Rujum el-Hiri, a 40,000-ton geometric monument on the Golan Plateau, aligned to the solstice by builders who left no name in the record. Nan Madal, an entire city built on the open ocean from multi-ton basalt columns transported across open water. The Shan quarry, where the most powerful administrative state of the 15th century cut and then abandoned stones it could not figure out how to move. And the Gateway of the Sun, carved without visible preparation marks into one of the hardest available stone materials at a site nearly 4,000 meters above sea level. None of these things require a dramatic explanation. They do not require hypothetical lost civilizations or technologies we have no other evidence of. What they require is honesty about the limits of our current reconstruction of ancient capability and a willingness to hold the gap open rather than close it prematurely with explanations that almost work. The honest answer in each case is that we have a credible explanation that accounts for most of what we see, and then a residual question that the explanation doesn't quite reach. That residual question is not the same across all 5 sites. The precision problem at Sacsayhuaman is different in character from the transport problem at Nan Madal, which is different again from the scale problem at Shan. Each gap is specific to its site, its materials, its culture, its geography. And that specificity is actually more interesting than a universal mystery would be, because it suggests that many different ancient societies, working independently, pushed against the same boundary from different directions. The boundary between what organized human effort can achieve and what the physics of moving large stone allows. What sits just beyond that boundary is not clearly defined. It may be a technique we haven't identified. It may be an organizational capability we've underestimated. It may be knowledge transmitted through practical tradition rather than written record, and therefore invisible to the archive-dependent methods of conventional historical research. Whatever it is, the stone holds the impression of it. Every fitted joint, every ground surface, every column lifted from a quarry bed and carried across open water, they are all records of something that happened. The question of what exactly continues to draw serious researchers back to these sites, season after season, with better instruments and more refined questions. The stones are patient. They have been waiting 12 centuries, 5 centuries, 4 centuries for us to get the question right. We are still working on it.